Hello everybody and welcome back. We're on question number 5, which in my opinion is probably the hardest one on here. It's very prone to errors and those sort of substitution mistakes where it's a common mistake. Everyone makes them at least once, but you try a substitution, that didn't work, you try another substitution, that didn't work, and so you just sort of get frustrated and you say, well, I'm done, I'm not going back, I'm not starting over again, I'm just going to work with what I've got and make it look right. And if you're not a trained mathematician, if you're the sort of student who's struggling and you don't remember all the rules, this is what's going to get you. And I really, really wish that people who didn't understand all the rules, first of all, I wish you guys would come to office hours. People don't come to office hours as much as they should if they're having trouble. But more than that, I don't like it when students say, well, I don't know, I need to get an answer, so I'll just guess, or I'll just try this thing that doesn't actually work. It's not a rule, it's not how math works, but I'll try it anyway because it looks right and it looks like one of the answers. No, don't do that. I let you guys have a mark for free if you leave it blank for this very reason. And with 4 marks and 5 possible answers, your average mark when you guess is 4 out of 5, or 0.8. 1 is greater than 0.8. So it is in your best interests to leave it blank, not guess. Okay, and this is exactly the sort of question where I see people do the wrong thing, and then they'll just say, well, I got frustrated, and this sort of looks like it might be the answer, so let's go with it. So what do we got? I haven't even gotten to the question yet. We are being asked to determine an indefinite integral, as is evidenced by all these plus c's here, 6x over x to the 4 plus 9. Yikes. Okay, so let's unpack this guy. And first I'm going to show you what I see a lot of people do. And we're going to talk about why that's wrong. And then we're going to go through the question properly. Okay, so I see a lot of people, they look at this one, they say, oh, it's polynomial over a polynomial. We did one like that in class. You might remember we did, I think it was 4x squared plus 9 or something like that. The x is on top and the really scary looking thing on the bottom. They even both have a 9. It must be like that. What did we do in that question? We let u be the whole bottom part. So that must be what I do here. And, it's not an unreasonable connection. We've seen other questions. Cos x over sine x, or sine x plus 1, and we let u be the whole bottom. This is going to lead to a ln of absolute value of u sort of situation. That's the connection that a lot of people make. So they see these things, they say, okay, that's what we should do. So I'm going to start this one off and say let u equal x to the 4 plus 9. See, these are connections people make, but they're ignoring why did we pick this u for this question from class. Why did this work? Because you might remember we had a very similar question that didn't have the x on top, it just had a 1. And we didn't let u be this. And I've had plenty of people in class when I've shown one that had, polynomial over polynomial. People say, well, I did, sir, I did this. I let u be the whole bottom, and I think it all worked out. And I said, did you get along? And they said, yeah, I did get along. And I said, yeah, but we got an arctan, or we got a u to the minus 1. Okay? People are really eager to learn to use lns. It's really nice. It's really simple. Just let u be the whole bottom thing. I don't have to think anymore. But we don't just say, let u be the whole bottom thing. That's not how it works. We have to be making connections. And so when we had the 1 on top, you actually had to treat it completely differently. You had to do an arctan sort of a thing. The only reason u works when there's an x, u being the whole bottom works when there's an x on top, is because the top has degree 1, and it looks sort of like the derivative of something that is degree 2, which is the whole bottom. That's not going to work over here. The top, yeah, it's degree 1, but the bottom is degree 4, and when I take the derivative of something that's degree 4, I expect a polynomial of degree 3. And you might say, well, this doesn't matter, it's one question, you're not even going to put this one exactly on the quiz, and if you are, I'm just going to memorize the answer. Polynomial over polynomial comes up a lot in whatever Calculus 2 course you take. Whatever Calculus 2 course you take. It's called the method of partial fractions. And if you don't learn this now, you're going to feel lost when they start doing that, because Calc 2, they tend to go through that quite quickly. So learn it now. Make the right connections now. No, oh, it's a fraction. I must just take the whole bottom part must be u. No, wrong. Bad habit. Break that as soon as possible. There's a reason why we do certain things. But, okay, let's continue on. So student is naively saying, well, I'm just going to take the whole bottom. Okay, let's watch that fail, and we'll see what a lot of people tend to do to try and recover from this. So as soon as I've made my u, I get my du, which will be 4x cubed. The 9 goes away. Now, I don't see a 4x cubed. I see a 6x to the 1. That's kind of the same thing, right? Well, we can, manipulate this stuff around, try and find the best thing to fit in, and really I think the best one to try and do is get everything, make dx equal something. You'll always have a du, but that makes it really easy to plug this guy in for your dx here. So we're ready to start substituting. There's no endpoints to worry about for this one. So the 6x stays where it is. The bottom part becomes a u. We're on our way to that 1 over u du that we all love so much. And the dx turns into du over 4x cubed. And now hopefully things will cancel out. Except they won't. An x will cancel out with one of the x's down here. And I can take the 6 over 4 out. And I'll be left with 1 over u du over x squared. And, we might conveniently just forget to put that on there. One thing we can do is, we can at least simplify 6 and 4. They both have a factor of 2, so I'm just going to make it 3 halves. And so what happens here? Well, what have I told you? You're not done the substitution until there are no more x's. Everything has to be in terms of u. But there's an x squared there. So we can do one of many things. We can do the right thing, which is admit defeat, and say, okay, this didn't work out. Let's try another substitution. Or we can do let's ignore the professor and integrate it anyway. Or we can ignore other math rules and do something like the following. This is what I see a lot of people do. The 4 and the 6 got to pop out. They got to pop out because they're constants. But people say, oh, the 4 and the 6 got to pop out. I'm not supposed to have any x's, so let's let the x squared pop out. And when I do this, regardless of the fact that it's not a rule and you're not allowed to do it, math is built off being exact. You can't just change the rules. If no one's ever taught you to do something like that, guess what? You can't do it. But, people take out the x squared and then they say, okay, well now this part here is ln absolute value of u. So then we plug the u back in and we get an answer. You get ln absolute value of u, but what's u? It's x to the 4 plus 9 plus c. And if we check over here, d, that's what is written there. Because I know you guys. I know what people do. My past classes have done this. And so, some of you out there will do this as well. And so you say, aha, I got an answer, let's move on. But you got an answer by breaking the rules, by cheating a little bit. And pulling the x squared out here, you say, well, why can't I do that? The short answer is because the math doesn't work that way. It's like if somebody came along to you and said, well, what's tan 5 divided by tan 3? Well, they just cancel out the tans and you get 5 over 3. And some of you out there will say, haha, yeah, no. Stupid other students. That's ridiculous. But some of you out there said, wait, it doesn't work that way? I see people try and cancel out the tans. That's not how functions work. We can try and make this even worse. So this is one I never see people do. 5 squared divided by 3 squared. That's literally 25 over 9. It's something we can actually calculate. But pulling the x squared out is exactly the same as saying, well, the squares cancel out here. So the answer must be 5/3. This isn't how math works. Okay? If math worked this way, a lot of things that you know and love in technology and science would not work. Okay? You got to play by the rules with math. And sometimes that's the hard part of a math class. You go to a psych class, you go to a history class, things are a bit more interpretive, they're a bit more subjective. You know, if you got the right essay question on a history final, you're good, because if you can just argue well enough, it doesn't matter whether or not you actually are right or wrong. Okay, you know, objectively in the historical sense, if you argue properly, essays, you can get 100%, even if the ideas you're espousing in your essay are absolutely wrong, you know, morally reprehensible or whatever. But in math, it doesn't work that way. In math, it's not, well, this looks right, or gee, I wish this would work, or well, they're not going to notice when I pull this x squared out of here. And so for a question like this, people, they always just say, well, I don't want to go back. I don't like substitution. You know, this x squared, I'd rather just pull it out and hope that that works, and ignore the fact that this isn't a rule, that this isn't how it works, rather than say, well, I must be wrong. Let me go 10 lines back and start again. People don't want to do that. You know, I agree. I don't want to do really long questions either. I also don't want to make really long videos where I rant and rave about how exact math is. Okay, so, you know, this isn't the way the question goes. Let's actually see how this one works. And it is a hard one. So let's get to the actual question. Okay. So here we go, and I take a look at this and I say, well, it's polynomial over polynomial. I don't know 7.4 yet, because we're not going to learn that in this class. So what am I to do? What connections should I be making? And you should stop and say, well, what things do I have? What connections can I make? And you could say, well, let's try the u as the whole bottom, but you'll find pretty quickly that that doesn't work. You won't be able to get rid of all your x's. Now, sort of a general rule of thumb might be to compare the degrees. If the top has a degree of, let's say, k, and the bottom has a degree of k plus 1, then roughly the bottom, the top is the derivative of the bottom. And that's why if this 4 were a 2, it would all work out. But in this case, we don't have that. Now, the other situation is if the degree of the bottom is 2 times k plus 1, this is prime for arctan sort of material. Because the thing I plug into, like arctan looks like 1 over... Arctan itself doesn't, but the derivative of arctan looks like this. And so when I integrate, I'll get arctan. So the derivative, the top has degree 0, the bottom has degree 0 plus 1, the thing I plugged into the square, and then we square it. Okay, that's how that works. So I would say, well, I've got a degree of 1 on the top up here. 1 plus 1 is 2. 2 times 2 is the degree 4 on the bottom here. So that might be one way to say, well, this looks like it's going to be a 1 over 1 plus x squared sort of affair. And if that were the case, what could we do? So we'll start the question over again. 6x, x to the 4, plus 9. As soon as we've decided I want to make this look like sort of 1 plus 1 over u squared, as soon as I decide I want it to look like this, maybe with some constants outside, I got to try and manipulate it so it looks like that. So we've got a 1 down here, whereas we have a 9 here. Let's take out this 9. So taking out a factor of 9 on the bottom, we'll turn this into a plus 1 at the cost of saying x to the 4 over 9. Now what else do we need? Well, I need something squared. Well, x to the 4 over 9 is a something squared. So we'll keep this 6x here. It's x squared over 3, all squared. And we might say, okay, that's a good candidate for u. So let u be x squared over 3, and then du by dx is 2/3 x. And that's looking a lot like what I have left over. I've got stuff in terms of x left over. Okay. So, well, I can't quite plug this in, but maybe if I say something like du is 2/3 x dx. I've got an x and a dx here, so maybe 3/2 du is x dx. And now we can substitute. So we get the 1/9, he stays outside. 6, and now I've got x dx all together. Get replaced with 3/2 du. And on the bottom, I get u squared plus 1. So there's a little bit of cleanup. The 6 and the 3, that's 18 divided by 2 is 9. So we'll get a 9 on the top. That can come out. So we'll get 9 over 9. And we'll have 1 u squared plus 1 du. But 9 over 9, that just goes to 1. So this guy is just going to be arctan of u plus c. But what was u? It's x squared over 3. And that's how we actually do the question. Once you've gotten onto this idea of it's arctan, it flows a bit more naturally. Turn any constants on the bottom into 1s by factoring out. The remaining stuff has to be represented as a square, and whatever it's the square of, that becomes your u. And once you try that, you'll get du by dx, and if the rest of the stuff can roughly be grouped so that it looks like du or du by dx, you'll be all set. So arctan x squared over 3 plus c, is that one of the possibilities? Arctan x squared over 3 plus c, that is e, that is at the very end. So it was a long question. Actually, the question itself was not that long. Probably I'd say 2/3 of the video was me ranting and raving at the start like a lunatic that you can't just do things because you want them to work out. Leave questions blank if you don't know what's going on in them or you just can't get them to work out. Seriously, on the level of probability, it is in your best interest to get that one guaranteed mark rather than just try and guess. I know it goes against what you've probably learned throughout your entire education system of if it's multiple choice, just guess if you don't know. And sadly, that's the way it works on the midterm and the final as well, but not on the quizzes. Okay, so, I'm sure this is like a 20-minute video at this point, but I will see you guys for the last question, question number 6, in the next video. I promise it's much shorter, and I also promise to stop ranting and raving like a lunatic. I'll see you guys next time.